Hello everyone, you are welcome to this lesson. In this video, you are going to learn about Newton's law of universal gravitation. This law states that for any two bodies separated by a distance r, the force of interaction between them is proportional to the product of their masses and inversely proportional to the square of the separation distance r. Let's look at what this law means. Okay, so assuming we have two bodies, okay, the first body with mass m1 and then the second body with mass m2, okay, and then the distance between these two bodies from the center of one of the bodies to the other is given as what? R. Then Newton's law is saying that the force of interaction between these two bodies, okay, will be proportional to the product of their masses and then inversely proportional to the square of the separation distance r, okay, and we can express this mathematically as F because J multiplying m1 m2 divided by r squared, okay, where the F represents the interaction force between the two bodies. Okay, so one thing you have to know is that these two bodies are going to exert the same force on each other but in an opposite direction. What that means is that the first mass, okay, will exert the force F on the second one, and then the second one will also exert that same force F on the first one but in an opposite direction, okay. So these two bodies are going to exert the same force on each other but in opposite directions. And then the R represents the distance, okay, from the center of one of the bodies to the other. Okay, so distance of separation. Okay, let's refer to it as the distance of separation. Okay, which is measured from the center of one of the bodies to the center of what? The other. Okay. And then G represents the gravitational constant. The gravitational constant. Okay, and then that is equal to 6.673 6.673, okay, times 10 to the power minus 11 meter cube per kilogram second squared. Okay, so that's the unit. Okay, and then m1 and m2, okay, represents the masses of the two bodies. Okay, the two bodies. Okay, so this is what Newton's law of what universal gravitation is about. Okay, so it tells us the force of interaction between two two bodies or masses that are at a certain distance are apart from each other. Okay guys, so let's look at a special case where we consider the interaction force between an object on the surface of earth and then earth itself. Okay, so in that case what we do is that we look at the earth, okay, and then we consider an object to be on the surface of earth, okay, where the mass of earth will be represented with m and then the mass of the object on the surface of earth will be represented with small m. So in this case we consider the distance between the center of earth and then that of the object to be equal to r, and then that is considered to be approximately the radius of what? Earth. Okay, so in this case our r, which is the distance between the centers of the two masses, will now be equal to the radius of the earth. Okay, so there's going to be a force of interaction between the object on the surface of earth and then earth itself, and then this force of interaction is now termed as the weight force. Okay, we term it as the weight force, which is represented with the letter W, and then that will be equal to the gravitational constant multiplying the mass of earth, then multiplying the mass of the object on earth divided by the radius of earth squared. This is what we do. So what we normally do is that we consider Jm, which is the gravitational constant multiplying the mass of Earth divided by r squared, and then we represent it with the constant g. Okay, I'm saying the constant g because we know the value of g, which is the gravitational constant. We know the value of the mass of Earth, and then we know the radius of Earth. Okay, so when you substitute all those values into this expression, we get g, which is known as the acceleration due to gravity, and then that is a constant. Okay, and then that has been calculated to be equal to 9.81 meters per second squared. Okay, that is if you are dealing with problems on the surface of Earth. Okay, we consider gm over r squared to be equal to 9.81 meters per second squared. Okay, so in this case, that we are looking at the force of interaction between a body on the surface of Earth and then the Earth itself. We can consider the g, which is the acceleration due to gravity, to be equal to 9.81 meters per second squared. Okay, so that's what we do. So in this case, the we can write the force as Jm over r squared multiplying the mass of the object on the surface of Earth. Okay, and then since Jm over r squared is equal to the constant representing the acceleration due to gravity, you can write the formula as J multiplying m. Okay, so in that case, we are going to have the force of interaction, which is the weight, to be equal to mass times J, which is the acceleration due to what? Gravity. Okay, so let's go back to the value G. Okay, G is equal to the gravitational constant multiplying the mass of the Earth divided by what? R squared. Okay, so one thing you have to know is that this value will change based on the position an object is on the surface of what? The Earth. Okay, so what will happen is that if the object, okay, if the object is at a distance very far from the center of Earth, then that means that r is going to increase, and then if r increases, then the value of g is going to what? Decrease. Okay, similarly, if an object is very close to the center of Earth, then r is going to decrease, and then if r decreases, then g is going to what? Increase. Okay, so let's take note of this. So although we consider g to be a constant, but it can change in some situations. Okay, let's take note of that. Okay, so this is the origin of the formula for the weight force. Okay, let's take an example. So in the example, we are going to calculate the force of interaction between an object on the surface of Earth and then Earth itself. Okay, so let's look at that. Okay, so the question says that calculate the weight force of a body of mass 675 kg at a location on Earth where the acceleration due to gravity is equal to 9.81 meters per second squared. Okay, let's look at how you are going to calculate this. So you see that the question was specific. Okay, it, it is telling us that we should calculate the weight force of a body of mass 675 kilogram at a location on Earth where the acceleration due to gravity is what? 9.81 meters per second squared. Because earlier on we learned that the value of the acceleration due to gravity can change depending on what the position of an object on the surface of what? Earth. Okay, so we learned that if the object is the distance between the center of the object and then the center of the Earth is very close, then the g value is going to increase. But if the distance is very far, then the g value is going to what? Decrease. Okay, so let's take note of this. So we are going to apply the weight force concept to solve this question. Okay, so let's look at that. So we know that the force of interaction in this case will be equal to the weight force, and then we learn that that will be equal to mass times the acceleration due to what? Gravity. And then the value has been specified for us since we know that it can change in some cases. Okay, so in this case, the weight force will be equal to 675 kilogram multiplying 9.81 meters per second squared. Okay, so let's do this calculation and see what you are going to get. If you do this, you are going to get 6 you are going to get 6.62 kilonewton. Okay, so that's going to be the weight force, which represents the force of interaction between the object on the surface of Earth and then Earth itself. So Earth is going to exert this force on the object, and then the object will also exert this force on Earth, but in an opposite direction. So this is what Newton's law of universal gravitation is about. It tells us about the force of interaction between two objects that are at a distance r apart. Okay, and then it tells us that these two objects are going to exert the same force, okay, on each other, but the force is going to be opposite in direction. Okay, so we learned that in a special case where the object is on the surface of the earth, we term this force as the weight force, and then that will be equal to the mass of the object on the surface of earth multiplying the acceleration